Hello, and welcome back to our e-learning series. Today, we'll dive into the differences between artificial intelligence, or AI, deep learning, machine learning, and data science. More and more, some of these terms have been used interchangeably, and it's time to provide some clarity about what they actually mean. This will be important in order to choose the right one to invest in for your next data project. Let's start with the most general concept, data science. Data science is a field that combines various skills and expertise. Essentially, it uses algorithms, statistical method, and programming to extract knowledge from data. In the previous video, we have already covered the process of a data science project. As we saw then, it calls upon numerous professionals to perform through a sequence of phases: data collection, data cleaning, data analysis, model building and validation, deployment, and maintenance. Data science in itself can use AI, deep learning, or machine learning methods to provide a data-driven answer to your business problems. In simple words, data science is the field that combines statistics, programming, and domain knowledge to answer business questions. So, what are the differences in the tools that data science calls upon? Let's start with machine learning. In essence, machine learning is self-explanatory. It refers to algorithms that allow the machine to learn from data. Machine learning has been around since the 1950s already. It's not something specifically new. Even though there are now hundreds of machine learning algorithms, we can categorize them into three classes. The first class of machine learning models is called supervised learning and uses labeled data. In other words, we know whether the algorithm is predicting correctly. Let's take, for instance, an algorithm trying to identify spam emails. This is a task that any of us could do. We know which emails are spam and which aren't. The algorithm is merely a way to automatize the process of deciding which are which. The main difference with the second class, unsupervised learning, is that it tries to analyze non-labeled data. Imagine that you're trying to separate your customers into different segments. These segments are not predefined. It is the algorithm that proposes a way to separate your customers into relevant segments. In this case, the algorithm tries to predict segments without actually knowing any prior segment in the dataset you give him. It tries to replicate how we, as human beings, would try to learn something entirely new. The last class is reinforcement learning. This kind of machine learning tries to replicate the effects of educating an algorithm. The learning process is based on feedback on whether the algorithm performed the task correctly or not. This is essentially what your Netflix recommendation system does. You provide the feedback that allows Netflix to provide you, or at least try to, with more relevant content. Deep learning will go a step further. Deep learning is trying to imitate how our brain works. It's based on what we call neural networks. These methods rely on the combinations of many smaller, simple methods, called neurons, that make a global algorithm capable of uncovering extremely complex relationships in your data. Up to machine learning, the learning process of the algorithms could be understood simply. That's no more the case with deep learning. Deep learning prefers performance over the interpretation of the results. For instance, let's say that you're trying to predict next month's traffic on your website. A machine learning algorithm would be able to predict that traffic with some error, but will also tell you what data is relevant in predicting the web traffic. This additional information is actually very useful in practice. As a business owner, you would like to know whether your new marketing campaign translated into more traffic, or whether it was caused by an external factor. Deep learning might give you a prediction with higher accuracy, but will not tell you which variables are important to make that prediction accurate. So AI is the field that combines techniques from machine learning and deep learning to mimic human intelligence. I think everyone now thinks first of ChatGPT when we talk about AI, but it's not limited to that. Generally, AI is separated into two sections: narrow or weak AI and general AI. Narrow AI is designed to answer only specific problems. The most common examples are Alexa or Siri, which are AIs developed to understand and answer queries as a human would. General AI, on the other hand, is a theoretical concept. It refers to an AI that is capable of replicating human intelligence in various domains. Understanding the differences between these key concepts will allow you to choose the right one to invest in for a particular project. For instance, using AI to predict sales over the next coming month is like buying a Tesla to drive and buy bread from a bakery that is 100 meters from your house. Yes, it will do the job perfectly, but walking there will do the same at a lesser cost. I hope that this video helps you gain some clarity about the field of data science and AI, and I'm looking forward to seeing you in our next video.